Jæja, það er bara allt að gerast. Mér finnst mjög gaman að sjá hvað margir komu því að í gæra voru 13 going og 130 maybe. Þannig að ég ánægði með maybe-ana sem kom í kvöld. Is there anyone here who does not understand Icelandic and doesn't want to admit it? But for real, if anyone is English speaking here, please raise your hand. Okay, so we can keep this in Icelandic. Sorry for anyone watching the recording. It's just too weird to speak English to only Icelandic people. Okay, that makes sense. Rotate this a bit. Yeah, it's good. Well, not much to announce except this is the second meetup in our series. That's a success. We'll try to keep it going. It might make sense to have it every 2 months and try to do something different in the odd months. For example, meet up for beer or something else, because it takes a lot of effort to find people to talk. But then instead we can try to make these talks more fancy. We're looking into all kinds of things like getting people like from another country to talk here. But then we will need to figure out the finances and we will have something to share about that later. But yeah, I'm not going to take the floor all night. So I'm going to introduce the first speaker. This is Ragnar Þór Valgrímsson, who works with us at Orangia, one of the partners there. And he's going to talk about a subject that I've been advertising this talk since November. And it was delayed twice. No pressure. So yeah, enjoy. Please give it up.
Does the mic work? Yes, okay. So before I start, I want to explain why I have 2 microphones. One of them is going to control my computer. So I'm going to try to control the slideshow only using my voice. So this may fail horribly. I don't know what can go wrong. And if it does, that's just going to be fun. Go next. Go next. So anyways, this is maybe the first talk of this quote-unquote decade. People are not in agreement if it's a new decade or not. Some people say it's next year, I don't know. To me, 2020 is like a new decade, so maybe the first talk. And I'm going to be talking about X states, but more generally, I'm going to be talking about state charts. Just by show of hands, does anyone here know what state charts is? Like 4 people. Okay, does anyone know what a state machine is? Okay, most people. And when I say state, often what comes to mind is something like React state, this.set state, and so on. Go next. But we are going to define state as a qualitative mode or status of a system. Go next. So this means it's not a data store. It has nothing to do with keeping the track of, the age or name of a person or I don't know what to keep in the state. Has nothing to do with React state, nothing to do with a Vue state. It's just in what status are you at a given moment. Go next. Go next. And if we take an example, a car is either stopped or driving. We are now in the stopped state, so we cannot be driving. There's no way for us to be both stopped and driving at the same time. Go next. Go next. Sorry? Then you're not stopped though. Then you're sliding. Yeah. Yeah. So when we go from one state to the other, it's called a state transition. And to make a state transition from one state to the other, in this case from stopped to driving, from driving to stopped, we dispatch events. Go next. So this is a state transition. And these three things, a state, a transition, and events, encapsulate a state machine or a finite state automata. Go next. Next slide. And this is like a definition of a state machine. It's basically an abstract machine that's always in a stable known state. And it's always determined by what state came before that or what state comes after that. So if you are stopped, you can't really stop again. You are just stopped. But you can't go into a driving state. And it's really easy to depict or demonstrate how a state machine works. Go next. By using a switch statement. So this is just a nested switch case statement, basically. The outermost statement is switching on the state. And the inner switch state is switching on the event. Go next. Go next. So if we visualize this, we are now in the stopped state. And this is like a hypothetical function, by the way. And we get in a new state, a new event. We are on the stopped state. Go next. Go next. Go next. Next slide. There we go. And if we dispatch an event called drive, we will transition to the driving state. Next slide. And now we're in the driving state. And for that state, we have events that can stop the state to go back into the stopped state or status. So as you can see, if you are in one state, you cannot dispatch an event and do something unpredicted. You can't, start flying or something, because that's pretty easy with regular if statements. Go next. Go next. Go next. Here we go. And if we look at the switch statement again, it's only these 6 keywords that we're really using. We're only interested in the states and events. So we're going to use a library called xstate to simplify this for us, simplify the tuple switch state, switch case statement. Go next. Go next. Into this thing. Go next. And now we only have a small object that represents our entire state machine. This is the same state machine that we had earlier with the stopped state and driving states. And we have events called drive and stop, which go to the corresponding states. Go next. But these kinds of state machines, if they grow, they're going to grow way too complex to be able to maintain. And go next. This is a state machine I found online. I have honestly no idea what it does, but it's super big and complicated, and it's not really easy to parse. And what a man called David Harald did in 1980 something, he created he published a paper on state charts, which will visualize the state machines in more complex systems. Go next. And David Harald did many things in this paper. He introduced many concepts to simplify complex applications and complex logic, and we're going to explore that a little bit now. Go next. Go next. But why should we learn another thing? And this is like, I feel like this is the JavaScript motto. Every year there's a new thing. There's also a new framework, new something. But the thing is that state machines and state charts are like 30 years old. They're old things. We're relearning how people used to do it. And NASA uses state machines to control the Mars rover and the Apollo space shuttles back in the day. So, I mean, they can't really, explode or stop driving because undefined is not a function. So, go next. We will have fewer bugs if we use state charts. There was research done that indicates that we have 80 to 90% less bugs if we use state charts. And the remaining bugs are bugs living outside of the state chart. So due to something else. Go next. We can reduce the mental effort of, us doing programming because we can stop trying to understand complicated code and just visualize how the app should behave. Go next. This is a typical code example from a async function. Can anyone spot the bug? Gonna give you like 10 seconds. Just by raising hands, can anyone see a bug? 1. There are actually at least 4 bugs in this code. And the thing is, they're really hard to spot. For example, we never reset the state if we have an error. We never stop a timer if we have an error. The is taking too long thing that we have there never resets. So if we finish this function and we have that message go up, we will always have it unless we run the app again or something. We restart the app. But this is really hard to understand, especially if you are doing a code review, if you are doing glancing code like we are doing right now. It's pretty hard. Go next. This is the same thing, but without bugs. This is the same example, and it's pretty clear what's going on. We have a state called searching. Within that state, we have a substate, which is instant. I didn't know what to call it, but after, that should have been 1,000 milliseconds, we show a message that says, the internet is slow or something. This is the same code as the code before, but just visually represented in a state machine, in a state chart. So yeah, go next. Go next. Another reason to learn state charts is to allow non-programmers to understand our code. Go next. It allows us to handle non-happy tough scenarios. It's quite often that we have applications that run perfectly well given the perfect conditions. But we never realize that the imperfect conditions can happen, and when they would happen, and how they would happen. But if we visualize our code, we can actually see it just by pointing and saying, hey, we're missing an arrow here. We're missing this state. We're missing an event. It allows QA teams to discover bugs and allows us to find errors more easily. Go next. Go next. And for us at HOP, we found that in code reviews, this helped quite a lot because when we have a complex logic change and a bunch, maybe like 1,000 lines of code that goes along with it, a simple image is going to help the reviewer quite a lot in understanding what's going on. Go next. So let's learn to code. Go next. Go next. I created a very simple app. Is it playing? I can't see it. Yeah. So this is basically a app to help me learn Chinese characters. It is basically just looking up character information, and it's a simple fetch request. And we can add it to our deck of flashcards that we can then look at later and study. But we are going to be focusing on the input we have, the lookup. Go next. So this input that we have, we type in the character and press search. It should have these requirements. This is our requirement list for that particular input. And we're going to build this using XState. And yeah, go next. So this is our state machine with collapsed states. We only have 3 states. We have the input, where we can type in the data, type in the characters. We have a searching state, which is kind of like a loading state, if you will, and we have like a detail view. Go next. Earlier I said that we have state, and state is not data storage. However, XState allows us to store data in a thing called context. So context is our data storage, basically. The thing that we have access to within the state machine. And actions, they run side effects. So we can run different actions based on transitions, based on entering a state and leaving a state. In this input scenario, we have focus and unfocused states. These are for UI animations. I don't know if you saw it earlier, but the label, it goes up and down when you click it. Go next. And the searching state, this is basically the same thing that we saw earlier on the faulty code thingy. And as you can see, we can visualize the code and we can interact with it using the XState visualizer, which is online. It's pretty good and allows us to interact with our code and learn how it works. In addition to regular state transitions, we have delayed transitions, which will happen automatically after a given time. and this is really helpful. Go next. And the final state is the detail state. This is the state where you show the character information, and yeah, it basically only has one event called clear, and that will just clear all data and take us back. And on exit, it runs an action called clear. And we also have on entry. Go next. Go next. So this is our final state machine for this entire component. I've added one thing there that I forgot to have in my code, and that's the search event. The search event has a condition. Is the green thing that you can see there is not empty, and that means that the transition only takes place if a condition is true, or yeah, true. So we can have a search event with many conditions that will go to the correct state depending on some previous condition. Go next. And we can visualize this and see it in the app. So as you can see, when you click on the input, it's going to animate the title, and you can see all of the states. And by the way, I didn't have time to create a toast, so I just created a plain old alert. Hope that's fine. Yeah. Is the alert up yet? I can't see. Yeah. So that's basically all of the states of the state machine visualized. And this is basically the most basic, most useful features of X-state and state charts, and that is to visualize your mode of status of your application. It allows you to create quite concise components in a JSON object format. You can share this component or this state tree with your React application, your Vue application, your server, I don't know, whatever, and it just works. Go next. However, I did not cover everything because this is a really dry subject. I realize that. It's just talking about this kind of makes me want to go to sleep. So, but it's really useful and it's awesome. The power is so good, but like it takes maybe a week to get familiar with everything. But once you are, it's so nice to work with state charts and state machines. I did not cover these topics. Parallel states, they are states that run at the same time. So in that case, you can be in the car, you can be driving and listening to a radio, or something. Driving and sleeping, maybe not, but actors is just the actor model, mathematical model, where you can spawn and subscribe to what's it called? Children? I don't remember the word. Anyways, you can create new state machines, run them, send messages, and receive messages from them. We have history states. They are useful for knowing which state you came from when you go back into a state machine. So, you leave work on a Friday, you remember you were replying to an email, you come back on a Monday, you pick up the email where you left off. That's kind of what history states are. Persisting states, you can rehydrate your state machine. from local storage or something else. Activities, they run during a time. So this is useful for subscribing to events or adding event listeners to an element because they live while the state exists. And implementation details, I did not cover those for a reason. There are so many different frameworks. We have Angular, we have React, we have Ember, Vue, and it doesn't really matter what you use because XState works the same amongst all of those. You just have different implementation details per framework. Go next. Go next. However, at Hop, and for those who don't know what Hop is a micro mobility platform. It's the scooters that you can rent downtown and drive around Reykjavik. We created that platform and app using XState. And I just wanted to show you briefly a few real use cases of XState. Go next. This state machine is basically our polling. It takes care of updating the vehicles on the map. And it's pretty simple and it's really nice to work with because we can see what's going on and what can happen in every state. And if we want to fix or add a new feature or something, it's quite simple. Go next. Go next. And then this is the thing that controls the entire app. Go next. Go next. And just to zoom in, this is like a portion of it. And if you are writing a state chart or a state machine, this feature, zooming in, is the best because you can look at one part of the state chart, one part of your application in isolation. And I just know that when I start the app, I will be in the initialize state, and then I'll go into the inactive state. I just know that by looking at this. And there's no other way into the app. Yeah, go next. And that's basically all for my introduction to XState, simplifying complex systems by introducing a new complex thing. Any questions? How would I introduce XState into a big code base? We actually did this for Hop. You can do this on a per component level. So you could just introduce one new component using XState. And then from there, add more components.
Out of batteries. Ignore me.
The third mic. This is awesome. Yeah, but you can add just to one component or one branch of your project pretty easily. So yeah, does that answer the question? Another question? Yeah. Yeah, so I forgot. Yes. What about dev tools? I forgot to mention that. This is one. You have, it's fine, yeah. There are dev tools. So the thing I showcased where you can click around the state chart, that's called XState Visualizer. That's kind of official. Other tools exist, and you can actually hook into the Redux dev tools. It works kind of, it's limited, but it kind of works. You can see how everything goes. And I've also seen dev tools extensions where you can visualize real time while the app runs how a state machine goes around business. It's kind of cool. Yeah. Anything else? Yes. Yes. Is the framework being actively contributed to? I think there was an update last week. So yeah, and it was like a new minor version with new features, and I think TypeScript support came 2 weeks ago. So yeah, pretty active. I have no idea how many contributors. No idea, but probably. Anything else? I have one question here that I wrote just for fun. Why not to use state charts? Because I didn't cover that. To answer my own question, I would not use state charts for hackathon projects. I would never use it for something that's you're supposed to deliver tomorrow, because at least while you're learning to use state charts and state machines, it is going to require a new way of thinking, and this takes time. But in turn, you get, better quality products. So yeah, trade-offs. All right. Anything else? Good. Thanks.
Thank you so much, Ragnar. That was awesome. We'll take a 4-minute break while we connect a new laptop and fix the mic. Please feel free to refill your drinks. Thanks.
Hallå? Oh, små feedback. Halló? Virkar þetta? Allt komið? Ok. Ok, ég hugsa að við byrjum bara. Þetta er óþægileg hérna þráður hérna. Færa þetta í burtu. Ok. Ótrúlega gaman hvað eru margir sem komu. Og vákað var hérna cool að sjá þetta rísa stage-art hjá Hopp. Það var ógeðslega cool. Vel hérna gott talk hjá Rögga. Ég ætla að halda þetta á ensku líka af því að ég held þetta síðast á ensku og ég kann ekkert að gera á íslensku. So I'm gonna switch to English now. This was originally a lightning talk, but I added a few slides. But it will probably be quite short. I haven't done it in a while, so bear with me if I have my phone to assist me here. I have some pointers, but let's just jump into it. So it might seem that there's something wrong with the title up here, but this is in fact one of the difficulties that you're going to run into as a developer if you're going to support languages like Arabic or Hebrew on your web pages. Any languages essentially that are read from right to left. And that's what I'm going to talk about in this talk now, but we'll get to this later. Allow me first to just do a brief introduction. My name is Tryggvi Gilvason. I'm a web developer working at Spotify out of the headquarters in Stockholm. And I'm working on the web clients team where we develop and maintain the web player and the desktop client. And I'm particularly interested in, at the moment, in accessibility and monitoring and product management and tech leadership. So if you like those things too, please, let's talk. I also am going to go to Loft Hostel later, so please join me if you want to go downtown afterwards. But let's get to the point. I see the screen is cropping off a bit there, but that's fine. So recently Spotify launched in North Africa and West Asia regions, and one of the languages that's spoken there is Arabic, which is a language that's read from right to left. And this talk is based on a blog post that my team wrote, which is linked down there. And it kind of reads as a kind of list of pragmatic suggestions when you're implementing a right-to-left layout on your web page. It's basically just a list of lessons we learned and the problems we ran into and how we solved them. Okay, so here in the top left corner you see the web player in Hebrew, and in the bottom right corner you see the desktop client in Arabic. And that's how they look today, more or less. They've changed a bit, but not much. I mean, Spotify hasn't changed much lately. Okay, so before we go any further, I just want to expand some of the acronyms that I'm going to be using here. So RTL is a string, let's call it a string, that you're going to see pop up a bit in the presentation, and that stands for right to left. And conversely, LTR is a left to right. So just to clear up any kind of confusions about that. Okay, so you're going to support right to left layout. The first thing you have to do is you have to set the base direction of text on the page. And this is done through a HTML attribute that's called dir, a direction attribute. So if you want to support right to left, or you know that user's preference is a right to left language like Arabic or Hebrew, then you will put the direction attribute on the HTML element, which will have this effect right here. So you have a paragraph in English that's right to left. So it's going to align everything in this paragraph tag to the right here. Sorry, I don't want to break your TV. And if you, this is the default, by the way. This is just like a regular paragraph in English. It's aligning here on the left instead of on the right. So that's the effect it has. But very quickly, you're going to run into a problem, because a lot of the CSS attributes that are kind of they have kind of an inherent direction baked into them, and this is for historical reasons, like margin left, text align right. You see the examples here at the bottom. So what can you do? You need to flip these attributes, essentially, or that's one way you can do it. You can use a tool like post CSS RTL, which flips all these asymmetric CSS attributes automatically for you and generates the new CSS. And you can just plug this into your build process. See if I forgot anything here. Oh yeah, if you're using Flexbox or no, that's the next. Wait a second. Yes, if you're using Flexbox or Grid, those don't have any direction baked into them, because these are newer standards which are aware of this problem. So, you know, flex start, flex end, it's just start and end, so the browser can choose for you where the end and start is. Okay. So let's say that we are using a tool like post CSS RTL, and we have a class rule definition there in CSS in the input, and we have these 3 rules in there. We run it through post CSS RTL or anything else, and it's going to separate out all the asymmetric attributes into these 2 new rules. So there's going to be one for left to right and one for right to left. And this is just targeting the closest element with a dir attribute there. And this, in case you're curious, this is just to keep the same level of specificity on the base rule. So in the future, and I'm super excited about this, someone should do a talk about that, we're going to get these things called logical properties in CSS that aim to essentially just fix this problem. So instead, in the future, instead of doing margin left, you're going to be using margin inline start. So there's going to be defined 2 axes. There's going to be the inline axis and the block axis. And you can, all the rules kind of are relative to these axes, and the browser can flip them whichever way you want. And it's going to support even other, it's called writing modes, the way you go, the kind of like the flow of text. And it's going to support like vertical writing mode, so you can have like a layout that goes from bottom to top or something like that. Yeah. Okay, so back to the title of the talk. That's the problem here. I'm going to try to explain this, and bear with me, it's a bit difficult to explain. But once you've set the base direction of your page to be right to left, you're going to see things like this happening in places in your layout. And I'm going to try to explain why this happens. So the first thing you need to know is that every character in Unicode has a direction, or it has information about the direction it is, the context of where it's flowing, basically. So the letters of the English alphabet, they all have the left directionality. And for example, like these glyphs here in Arabic, I don't know what they're called, but they flow from right to left. And there are also symbols that don't have any direction baked into them, like the parentheses and punctuations and stuff like this. So what's happening here is there's an algorithm in the browsers called the Unicode bidirectional algorithm, which is applied to every text node when you have UTF-8, I think, as a character set on your browser. And it parses the string from right to left, and it encounters, let's start here, it encounters the closing parenthesis here, and it sees this is a this is a non-directional character, and the base direction of text on the page is right to left. So I'm gonna flip it. And then it goes to the D, and it says, oh, this character is a left directional character, so I'm gonna leave it alone. And it does that for all of the English characters until it reaches the opening parenthesis. And then it's gonna say, okay, so the prevailing direction, the previous direction was left to right, or like was left, so I'm just gonna keep that as well. So it keeps everything except the first parenthesis. Okay, and here's another problem. Let's just start with your problems. And they both have the same fix, and we'll get to that. But you'll get cutoffs at the beginning of sentences. So if you have the base direction as left to right, your Arabic sentences will cut off at the start, and if you have it as left right to left, your English sentences will cut off at the start. So it feels like it's an impossible problem, right? You're just like stuck there. Ants of my heart instead of dance of my heart. So the fix here is to basically give a signal to the Unicode bidirectional algorithm, it's a mouthful, to make a trade-off. Basically, you tell it to make a more sophisticated and slightly more expensive pass over the text, and basically say, hey, there's dynamic content in there, we don't really know what it is, so please don't make too many assumptions. And that's how you do it. You set the direction to be auto. You're essentially saying, I don't know what it is, just figure it out, try to do your best. So, more issues we ran into. In Arabic, it's best to avoid serif fonts. Like the default fallback for Arabic in browsers is Arial, which we got feedback from users that it was very illegible. You can see the comparison here, it's quite hard to read. So we actually, we used, I think it's Noto, we used Google Noto first, but then we got our own font. At Spotify we have a font called Circular that we use. So that's, I think that's Circular. We also bumped the base font size up from 11 pixels to 12 pixels just to get it a bit more crisp and readable. Another problem is that the glyphs in Arabic can overlap. So using transparency in text colors, it doesn't really work. It's a cursive font, so all the characters are connected. So I don't know if you can see it here, but there's like a slight difference in the coloration here in the text. So what we needed to do is basically we avoided transparent text colors like RGBA or like anything like that as a whole, and we just used a completely opaque color and then lowered the opacity of the whole element. And that seemed to fix the problem. It might be considered as a browser bug, I don't know. Yeah, last issue is because the glyphs are taller than in, and this is not unique to right-to-left languages. This is if you're supporting, especially Taiwanese. It's infamous for being introducing this problem where the characters start to cut off on the line where you are, either at the top or at the bottom, because they're so tall. So you need to kind of just go in and try to find all those places. And there are more issues. So Arabic doesn't have the concept of capitalizations. There is no capital letters in Arabic, and Hebrew, I think, as well. Sorry if I think this talk is quite biased towards Arabic because that's kind of where the blog post was written from, but we support more languages now than Arabic. Anyway, it doesn't support letter spacing either because it's a cursive font. So you're basically ripping all the characters apart if you introduce any letter spacing, and it looks awful. So we had to remove all letter spacing in Arabic and all capitalization. Well, it doesn't really have any effect. So what you need to think about if you start using this is if you're using capitalization and letter spacing as we were doing to introduce hierarchies in the page or distinguish content, that's not going to have the same effect. So you can see here your library is quite distinguished from the the members of the library, while here it just kind of blends in. So that's one thing to think about. Another thing is to think about is that Arabic uses a different delimiter for lists. So the comma in Arabic looks like that, while the English comma is like the regular comma. And we had quite a few places where we were joining strings with a comma like this. So we needed to change that, and we basically just picked the delimiter based on the language. But I know there's a better way to do it. I think you can use the list formatter API, which is part of the browser's internationalization APIs now, that can do this for you. List format, I think it's called. And there is also exceptions, of course. So this is kind of fun. You don't flip media controls. You don't flip playback progress. You don't flip volume sliders. And the reason for these exceptions, I think I dug this up on the internet. It's because like people there, the users there, they got used to the layout and the arrangement of the audio hardware devices like VCR players and CD players and things like this in the 80s when they came around. So when they saw this on the web, they expected it to work the same way as the devices in their homes. So one thing we wanted to look at as well is how do we keep quality up in this experience? Because none of the developers on my team are going to be using the client in the right-to-left Arabic experience on a day-to-day basis. So how do we make sure that we don't degrade or break this experience for users? And there's a few options that we discussed. One thing we discussed was visual diffing. We didn't end up going down that route because they're quite expensive to implement and they can be quite a maintenance burden and are inherently more flaky than other solutions. So what we came up with was basically like a cheap thing. We built a little GitHub bot that nudges you just to check your experience in your PR if you're introducing any of these asymmetric CSS attributes, either in CSS files or in JS files. It has these irregular expressions that it just parses your diff with and nudges you to check it out. You even have to like check a little checkbox. That's all. Thank you. Is there any? This is very distracting. Any questions?
What did you write the top of?
Node. Yeah, it was a Node script using the GitHub API. Yeah.
I noticed you never flipped the entire setting, so let it be, then you become HD left. It cannot left that way in the right way. Is it just aligned to the right?
That's right. So if you have English content, they read it from left to right as well, because that's how English is structured. So if you would have mixed content in the sentence, for example, you would start reading from right to left, and then you would switch to the English part, and then go, yeah. Back there.
What is the difference between right to left, left to right, and text align right and text align left?
I guess text align is just overwriting the default. So if you are in right to left mode, everything is text align right, left, right by default. Yeah. Yeah.
Isn't that just the difference between sort of a visual indicator where you should start versus the way you actually see the test align thing? Would that be a way to explain?
I'm not completely sure if it's just flipping it exactly like that, but if you're in right to left, it's gonna if you have a header, for example, that is a big box that takes the whole page, it's gonna start in the left part, right? If you're a website, if you put right to left, it's gonna go to the right part, even though it's English, right? So it's gonna kind of like align to the end of the header. Hope that explains it. Yeah?
So I noticed in some screenshot that parts of the Spotify player, which we're used to being on the left or the right, like the translating tool or something.
Yeah, that's the first slide.
Yeah.
This one.
Yeah, exactly.
Yeah.
So I guess that you would, how could you like, is it, do you have different building for these types of right to left version on Spotify, or like we're using React to right to left and we try to do this, or what are you doing?
So, yeah, so thank you. Yeah, I've been forgetting to summarize all the questions so far. So the question was basically, do we have different builds or different files? Correct me if I'm wrong. For like the right to left experience and the left to right experience. So answer is no. We opted for this approach where we bake it into the same file right next to each other. So all the rules are in the same CSS file, and you just flip it with, you target the attribute basically on the HTML element. You could go for splitting it out into different CSS files if they get too big. Actually, something I forgot to mention is this is what we did on the desktop player, because we can bundle the assets. We don't have to fetch them over the network. On the web player, we actually do this manually to get less lines of code. Yeah. Sorry, can you say that again? Yeah, I think, I mean, isn't it like the language? Yeah. The question was, if you can set a preference in the user agent or in some way to always pick the right to left language. So I guess, I guess you can, so we listen to like the navigator language on the web player, for example, which I think is based off the language header with the initial request, or whatever the header is called. And then we, serve the right translations, and we just save that preference for that user. Yep.
One question is not directly aimed at this left-right problem, but do you use any platforms or tools to manage the translations of all languages?
Yes. Yeah. Basically, are we using any provider or platform to handle all the translations at Spotify? Yes, we are using a vendor called Smartling to do this for us. Yeah. All right. Thank you. I think pizza's arrived.
Thank you so much, Tryggvi. So yeah, this is the end of the scheduled talks. The pizza's just arrived, as you probably smelled. So yeah, please enjoy the food and the beverages, and maybe you want to talk about the plans after?
If anyone wants to continue to talk about tech stuff or go grab a beer, then I was thinking about going to Lofthostel, but yeah, later. It's quite far from here though, but that's what I put in the event, so that's where we're going. Yeah, yeah, hook us up with 30 bikes.
Great, thank you so much for coming. Thanks.